This is one of a series of good answers presentations, offering evidence to answer skeptical challenges to the Bible's accuracy. As many know, liberal critics concentrate much of their fire on the book of Genesis. They argue that much of the book is mythic or legendary, or even simply fictional. And when the subject is Genesis' early chapters, describing the creation of the world, their criticism turns to scorn. Science, we are told, now provides a solid explanation for the beginnings of the cosmos and of our planet, and it relegates the biblical account to the status of myth or poetry. But let me suggest that the evolutionary account of the universe, with its tale of billions of years of star development since the Big Bang, has some serious problems. Follow me, if you will, while we take a look at blue stars. The age of the universe is deeply controversial. Listen to various spokesmen on television, and you will hear some tell you that it is only a few thousand years old. Others, such as Bill Nye the Science Guy, put its age in billions of years. A famous author recently told a journalist about how the disagreement troubled him when he was in his early teens. I remember saying to a minister, "I don't get it. I read a book that said there was an explosion known as the Big Bang, but here it says God created heaven and earth and the animals in 7 days. Which is right?" That was Dan Brown, author of the Da Vinci Code, recalling when he was age 13. He went on to tell how failure to get a satisfactory answer led him to give up the Christian faith. Well, are there any good answers to this fundamental question? Although we often hear that only ignorant people will deny evolution and the billions of years it requires to do its work, there are actually many scientists who challenge that theory. One of them is Dr. Jason Lisle, who holds a Ph.D. in astrophysics from the University of Colorado. He points out that the presence of blue stars in the skies is powerful evidence that the universe cannot be billions of years old. Let's look at what he has to say. We should begin with colors. Not only is the night sky alive with countless points of light, a tapestry of beauty to put us in awe of our Maker, but those stars vary in color. A famous constellation like Orion the Hunter provides us with examples of this fact, with blue, white, and red stars making up its shape. This chart shows us what the colors imply. Though all stars are bright and intensely hot, they display a range of luminosity and temperature. Red stars are relatively cooler than others, and they are correspondingly less bright. Betelgeuse, in the shoulder of Orion, is one of these. Yellow or white stars, like our Sun, are hotter, and they emit more light as well. But the brightest and hottest stars are the blue ones. Alnilam, center star in Orion's belt, is a stunning example of these. All stars, of course, are giant furnaces, converting hydrogen into helium in a thermonuclear reaction that releases immense quantities of energy. Our Sun, being the nearest example, has been the easiest for us to study, and it's classed as a medium-sized yellow star. Despite the fact that we can't look directly at it in a clear sky, it is only medium in brightness as well. Many other stars are brighter, but with its supply of hydrogen, scientists estimate that it could continue to shine for perhaps 10 million years. What about blue stars? They are, for the most part, larger than our Sun, and they are most definitely brighter. Alnilam, center star in the belt of Orion, is 275,000 times brighter than our Sun. To achieve that level of brightness, blue stars are burning their fuel at a much higher rate than red or yellow stars. Their brilliance comes at a cost. Scientists inform us that a blue star will burn itself out in less than 1 million years. Notice, our Sun can expect a lifespan of perhaps 10 billion years, while a blue star, any blue star, will last only about 1/10,000th that long, less than 1 million years. So, if the universe is, as we are told, some 14+ billion years old, shouldn't all the blue stars have burned out long ago? Most of us know the answer to that. New stars are being born all the time. Telescopes that can look deep into space, the Hubble is the most famous of them, have shown us what are called stellar nurseries. And are they ever beautiful? Here are some examples. The Tarantula Nebula, Messier 17, the Carina Nebula. These are, of course, vast clouds of interstellar gas that we are told are in the process of producing stars even as we watch. And watching these, we Star Trek fans can almost see the Enterprise coasting by. What's the process? Well, the word is that gravitational attraction will cause these gas clouds gradually to collapse upon themselves. And what happens next? We'll see, they tell us, a birth in the nursery. As the cloud collapses, with the resulting increase in density and heat, it will reach a critical point, and the nuclear fires will ignite, and a star is born. It's a beautiful scenario, but unfortunately for that theory, there are problems, big ones. Here's the first. We all learned in school that there are 3 possible states for matter: solid, liquid, or gaseous. Heat ice, and you get water. Continue heating it, and you get steam. The difference among these 3 states is simply how fast the molecules are moving. In a solid, very little. In liquid state, more motion and faster. And in the gaseous state, those molecules are moving very fast. Those fast-moving molecules mean that any gas will expand to fill whatever container it's in. So what about those clouds of gas in space? Here, there is no container. Given their gaseous state, those clouds of hydrogen we see should not be collapsing. They should be continuing to expand infinitely. And that's just what they are doing, expanding. People may call them stellar nurseries, but the process is working the wrong way to make new stars. If we ask our astrophysicist, he'll tell us categorically, star formation has never been observed. But that's not the only problem with this star formation scenario. Let's go back to school again for a moment to review a chemistry fact. Boyle's law. Remember this one? Put gas in a cylinder with a piston atop it, and we'll do a little experiment to illustrate the law. when the piston is up and the gas has relatively more room, we can check the pressure and find it rather low. More volume, less pressure. Then push the piston down. Now we have reduced the volume that's available for the gas to occupy. What happens? As the volume decreases, the pressure increases. Boyle's law, just like our sophomore chemistry class. Notice what happens then if we assume that gravitational attraction will cause that gas cloud in space to begin to collapse into itself. As it collapses, its volume decreases. Boyle's law tells us what will happen. The gas pressure will increase, counteracting the gravitational attraction and defeating it. Result? The cloud of gas will never collapse enough to give birth to a star. We don't need an expert to tell us this. Our high school chemistry teacher already made the point. But we could consult Dr. Lisle again anyway. Quote, "In a typical nebula," he says, "the gas pressure far exceeds the minuscule force of gravity." Nor is that all. There's a third problem with this star formation scenario. All the gas nebulas we observe, as we're informed, are rotating in space. Here's an example of rotation we've all seen. A skilled ice skater performing her routine. With arms extended, she starts a spin. Then she pulls her arms in, and we've all seen what happens. The speed of her rotation increases the more she draws in on herself, and the audience applauds. Here's an example we can all enjoy. Natalia Konunikov sets a new world record, spinning at over 300 revolutions per minute. Can you imagine the centrifugal force she's enduring in that spin? One wonders if she doesn't have to keep her eyes shut to keep them from popping out. What happens when we apply this basic principle of physics to our gas cloud in space? It's already rotating, as we know. As it begins to collapse onto itself, its angular momentum will increase, and centrifugal force will come into play, driving the cloud back outward again. Once again, the cloud collapsing scenario fails, this time on a law of physics. Let's put all these issues together. Now, the mutual gravitational attraction of the molecules in a gas cloud is real, but it seems to be too weak to prevent the gas clouds we see from continuing to expand. Expansion is, in fact, what we see with every nebula we can observe. But let's assume that there are some that are beginning to collapse under the influence of their own gravity. Then let's chart the factors that will be at work on those clouds. As they get smaller, gravitational attraction actually does increase as their density increases. But there are the other two forces at work. With increasing density, the internal pressure of the gas increases far more than the gravitational force does, and cancels it out. And then there's the rotational issue. As the cloud draws in on itself, its rotational speed increases, and the centrifugal force generated far exceeds the slight increase in gravity. Either one of these forces is enough to more than cancel out the force of the cloud's gravity, and together they completely overpower it. Result: the cloud simply cannot collapse. Now, what we've seen here is basic high school physics and chemistry. Without doubt, astronomers mastered these principles long ago. So how can they continue to say that gas clouds in space are collapsing and forming new stars? They have never observed the process, not even the beginning of it, and the laws of physics and chemistry say it can't take place anyway. But you see, ever since Darwin, our Western culture has bought heavily into the theory of evolution, and that theory absolutely requires billions of years. As a result, those astronomers who operate from that basic worldview have no choice. They have to believe that some unknown process must be at work to produce new stars. The fact that they don't know what that process is a profound embarrassment. Well, there is one theory that has been proposed. Granted, the gas cloud can't collapse on its own and form a new star, but maybe something forces it to collapse. Some astrophysicists have theorized that exploding stars, novae or supernovae, could provide the external pressure needed to overcome these impediments and force the cloud to collapse. But here, too, there are problems. First, to squeeze the gas cloud, we would need it to be surrounded on all sides, and in the 3 dimensions of space, of course, with all of those stars becoming novae more or less in synchronization. What are the odds that something like that could occur? It has certainly never been observed. But even if it could, it doesn't solve the most basic problem. How did the very first stars form, with nothing else in space to press on them? Let's not lose sight of the importance of this question of star formation. For the universe to be billions of years old, it has to have been producing all kinds of stars, red, yellow, white, and blue, throughout its history. And as blue stars burned out after their short million-year lifetime, they must have been replaced. But how? Time to review. Blue stars, brilliant and intense, burn through their nuclear fuel at a great rate. By general agreement, a given blue star can last only about 1 million years. Against the background of the multiple billions of years that we're told the universe has lasted, this is little more than a flicker. Blink, as we say, and you'd miss them. So there must be a mechanism to replace them, to create new stars. But those immense, gorgeous gas nebulas, often called stellar nurseries, are nothing of the kind. First of all, they are not collapsing as required. They're expanding. And what's more, they can't collapse. Boyle's law states that if they begin to shrink, their internal pressure would rise and overwhelm the gravitational force that was shrinking them. And the fact that they are rotating means that as they drew in, their speed of rotation would increase, and centrifugal force would build up, far exceeding the pull of their gravity. Therefore, science knows of no set of natural causes that can produce new stars. Is this a problem? It is indeed, and a huge one. Clara Moskowitz offers a quotation we should all hear. Quote, "How star formation began is very much a controversial question. said astronomer Mordecai Mark Maclow of the American Museum of Natural History in New York, who wrote a paper featured in the journal Science Today, June 28, 2013, and it's an important one, end quote. Knowing what we know now, and hearing what the evolutionary spokesmen say about the age of the universe, there is only one possible conclusion. All of the blue stars should be gone by now. That gives us reason to ask, is the universe billions of years old, as evolutionary theory requires? Well, if it is, then all of the blue stars are gone by now, right? Right. If you have questions about this lecture, or any of the others in the Good Answers series, you may direct them to me, Dr. Jerry C. Four, at yahoo.com.